Hi everyone, and welcome to our first daily booster for the chemistry paper. To start off our chemistry boosters then, we're going to have a little look at atoms. So we'll have a look at particle theory, we're going to have a look at the structure of atoms and who actually came up with that entire theory behind them. First thing then is, when we're talking about things that are actually too small for us to see, then what we do is we use these things called models. Now, models are a great way to try to solve problems and develop scientific understanding for things that we can't always just get out and show to everyone. It's not like in chemistry class we could get out an atom and we could all sit and look at it, because they're far too small. So what we developed in terms of particles is the particle model. And the whole idea of this is it gives a way to describe the arrangement and movement of particles in those three key states of matter: solid, liquid and gas. From our understanding of the particle model, we can then explain some key properties. So the first one is about the ability to compress things. We can only compress a gas because there's space between the particles. We can't compress solids or liquids because there is no space between the particles, therefore there's nowhere for them to go. Solids are the ones that can't flow because the particles are actually in fixed positions and they only vibrate around a fixed point. Liquids and gases, they can flow because the particles are free to move over one another or around each other. This is a super handy little table to learn, because what we've got, the three states of matter in the first column, a reminder of the diagram of the particles in the second, and then we talk about the arrangement, the distances and the movement of the particles. What we need to be careful of is, if you are asked to draw a diagram of these particles, first of all, if it's a solid, make sure they are in nice neat rows, all nicely touching. If we're talking about a liquid, don't just draw a solid again. So they need to be touching, but they can't be in neat rows. So what people tend to do is they end up drawing a couple of particles joined together, but they've drawn a gas as basic molecules. So you can't have these big open spaces, otherwise it's a gas. Instead, look at the picture for the liquid there. We've only got all those particles touching. There's a couple of small gaps between them, but nothing considerable at all. So go careful with how you draw liquids if they ask you to. In terms of the arrangement, as we've already said, solid is the regular one and they're very close together. They're all touching and the sum total of their movement is vibrating around a fixed point. For the liquid, it's a random arrangement. They are close together, but they are capable of moving around each other, hence why it flows. And the gas, it's random, they're far apart and they move quickly in all directions. There are some diagrams that we can use that are not just that flat representation we saw in the table. We could draw them three-dimensionally like we have in this picture here. Bear in mind though that when we're drawing this kind of 3D structure, it's still not perfect because some of the particles are hidden from view, either in part. So if we have a look at this one here, you can see that we're missing this little corner of it. So we've actually missed that part there of the particle. Others in the middle, completely hidden. We don't even know they're there. So 3D models still had limitations. The next bit is looking at the difference between physical and chemical changes. A physical change is a change in state. So this is ice melting, something dissolving, something evaporating. All of those are just changes in state. Key things about a physical change: they are reversible and we are not making a new substance. When ice melts, it started off as H2O in ice, it's still H2O as a liquid. Chemical changes though, these are going to produce one or more new substances through a chemical reaction. And because of that, they tend to be irreversible, so we can't get our reactants back afterwards. And the properties of our products are quite often very different to those of the original reactants. Do remember, as far as a physical change goes, the particles don't change, they stay the same because there's no reaction. We would have the same particles. The only thing that's changing is the arrangement and the movement. Chemical change, that isn't true. Literally, the way the particles are arranged is changing. So they're breaking apart from one another and then rejoining in a new way. In terms of what holds these particles together, the phrase we need to know is electrostatic forces. What we actually find is that we've got forces of attraction between positive and negative charges. And that's what's holding the particles together, is these interactions. The further apart the particles are, the weaker the forces will be. Now, when we think about the particle model with our little balls that we use to represent our particles, there's three things we're not actually taking into consideration. The first are any forces between the particles. Secondly, the size of the particles. And third, the space between them. So just bear in mind that we do have some limitations with this particle model, and that's that we're not taking those three things into consideration. There are three key terms that we really need to understand so we use them correctly throughout our chemistry papers. First, the word element, and this is a substance whose atoms have the same atomic number. Second, atom, the smallest particle of an element. Third, a molecule, that's a particle that consists of two or more atoms that are chemically joined together by those structures called bonds. They could, as one of the maths questions, ask you something related to bond sizes, for example. Now, what we've got there is just a nice simple one to remember, that atomic radii and bond lengths are typically around 10 to the power minus 10 meters, or 0.1 nanometers. So just make sure that you do remember that bit. The next thing we're going to look at is the actual structure of an atom. So hopefully the little diagram on the bottom left corner there is super familiar to us. In the center we have the nucleus, and the nucleus consists of the protons and the neutrons. And then around the nucleus we have these shells or orbitals, which is where we find the electrons. The table in the bottom right corner, hopefully we could recreate that in our sleep by this point. You need to know the three subatomic particles, proton, electron and neutron. You need to know the relative mass and the relative charge for each of them. They do like this as a little gap fill exercise, so it's not worth a vast number of marks, but it could be worth a couple of marks to you. So protons, mass of 1 and relative charge +1. Neutrons, mass is 1, relative charge 0 because they're neutral, so no charge. Electrons have a relative mass of 0.0005, or 1/2000 if you prefer, and a relative charge of -1. Please make sure you know that table because, as I say, it is one of their little favourites. We've now got a couple of other key terms we need to know, atomic number and mass number. When we're talking about the atomic number, this is going to tell us the number of protons or the number of electrons. In an atom, they are the same. So however many protons you got is the same as the number of electrons. The mass number, this tells us the number of protons plus the number of neutrons. So if you wanted to work out how many neutrons there were, all you do, mass number minus the atomic number. Next key term, the word isotope. When we are talking about an isotope, this is an element with the same number of protons and electrons, but a different number of neutrons. Can be a 2-mark question just for the definition there. First one is for saying it's got the same number of protons and electrons. Second one for saying it's got a different number of neutrons. We could phrase it a slightly different way, saying the atomic number is the same, but the mass number is different. Last one I've put on there as a key term is the word ion, which is just a charged particle. Could be positive, could be negative, but it is charged. Key thing to remember as far as ions go is that they are going to form when electrons are either gained or lost. Only the electrons are going to be moving. So if electrons are gained, bearing in mind that electrons have a negative charge, the ion will have a negative charge. If electrons are lost, then it will have a positive charge. The next little bit we need to understand, and the last little bit of today's booster, is the different scientists involved in developing this structure of the atom that we know today. First one we go back to is John Dalton, and he came up with this idea that all matter is made of atoms, and that these atoms are identical in one element, but different elements contain different types of atom. He described them as tiny, indestructible spheres. If you remember only one thing that Dalton came up with, tiny indestructible spheres is the phrase to stick in your head. Next up is Thomson, so J.J. Thomson. He was the one that discovered the electron. Now, he carried out experiments called cathode ray experiments, and by observing what happened to those beams, he then came up with the idea that cathode rays are actually tiny negative particles, which he called electrons. From that, he then devised what we refer to as the plum pudding model. So what that means is we've got basically a positive cloud, if you like, with these little negative electrons scattered through it. Third scientist is actually a trio of scientists, Ernest Rutherford, who worked with Geiger and Marsden. They carried out these experiments on very thin sheets of gold foil, and they fired these beams of positive charged particles at them. These were called alpha particles. If the plum pudding model had been accurate, these alpha particles would have just passed straight through, but they didn't. Instead, they changed direction in some cases. So that suggested there was something stopping them just going straight through this thing called the atom. And Rutherford came up with the explanation by saying that atoms have a positive nucleus and the electrons orbit like planets. And that brings us to our final scientist we need to know for this particular course, which is Niels Bohr. And he then came up with mathematical models to show that these electrons actually occupy fixed energy levels or shells around the nucleus. Head on over to have a go at today's quiz then, so you can see the link there and also in the description box underneath. And obviously don't forget to join us again tomorrow for our next Daily Booster.